Greenhouse warming theory is rapidly becoming the most expensive mistake ever made in the history of science. Video 4. Sequences of major explosive volcanic eruptions cause slow, incremental global cooling. On June 15, 1991, Mount Pinatubo in the Philippines erupted 2.4 cubic miles of debris as high up as 22 miles into the stratosphere within 9 hours. This was the largest volcanic eruption since 1912. Water vapor and sulfur dioxide ejected into the lower stratosphere formed a sulfuric acid aerosol, or mist, that was observed from satellites to spread around the world in the tropics within 21 days and to spread poleward within a year. The droplets within the aerosols were observed to grow large enough within months to reflect and disperse sunlight, causing global cooling of about 0.5 degrees Celsius for 3 years. All major explosive volcanic eruptions observed throughout written history have been followed by similar global cooling. The 1815 eruption of Mount Tambora in Indonesia, the largest volcanic eruption since 1257, was followed by average global cooling of up to 0.7 degrees Celsius. The next year, 1816, was known as the Year Without Summer, when average temperatures in Europe dropped several degrees and hundreds of thousands of people perished due to crop failures. Since 1800, there have been 6 eruptions as large as the Pinatubo eruption and 14 smaller eruptions that were large enough to form aerosols that cooled Earth for at least 2 years. Nearly all heat in the ocean atmosphere system is stored in the ocean, which covers 71% of Earth's surface. Modeling of ocean temperatures and modeling of mean sea level show that when the ocean surface is cooled by 0.5 degree for a few years, the effects of this cooling can be observed in ocean temperatures 100 years later. Thus, sequences of explosive eruptions can cause slow incremental cooling of the ocean, modeled as a small decrease in sea level in this plot. The more numerous the eruptions, the faster the cooling. In deep-sea sediment cores, the temperature of the ocean at the time a tiny animal forms its shell can be estimated by measuring the ratio of oxygen isotopes in that shell. This figure shows how these temperatures document in detail a much longer period of slow incremental cooling from the last interglacial period known as the Eemian climatic optimum 120,000 years before present to the last glacial maximum around 20,000 years before present. Nearly all major explosive volcanoes are found today in the so-called Ring of Fire surrounding the Pacific Ocean, where ocean lithosphere, shown in the lower left, is being subducted down under continental lithosphere. Subduction-related volcanoes are most active when the rates of subduction are highest. The most recent ice age, the Pleistocene, appears to have been caused by major increases in the rates of subduction of lithospheric plates under continents around the Pacific Ocean, beginning 2.6 million years before present. Rapid onset of glaciation in Antarctica 34 million years before present is contemporaneous with rapid increases in the rates of subduction all around the Pacific Ocean. Worldwide glaciation approximately 650 million years before present, referred to as Snowball Earth, was contemporaneous with subduction along the edges of nearly all continents. Thus, each major explosive volcanic eruption is observed to cause short-term global cooling of about 0.5 degree Celsius for a few years. Several such events per century are shown by modeling to cause slow, incremental, long-term cooling of the ocean. When such rates of explosive volcanic activity continue for millennia, they cool global oceans down into ice age conditions. Thank you.